In this series, we're going to look at measuring. This will be conducted under the Australian and New Zealand Standard of Measuring. This standard is recognised worldwide, but please check your local building code for any differences. We're going to follow a certain project all the way through. Today's video is on timber piles. If you've enjoyed this video, please don't forget to like and leave comments below. So when we start a new project, we need to put a heading in. We need to give an understanding what the project is. So in this case, it's a 2-bedroom house, and also the address, as well as the information on who is doing the works and the date. So in this case, the address is 23 Morris Street. It's a 2-bedroom house. It's completed by Michael Rowland, and the date is the 28th of the 1st, 2025. So we're looking at the foundations now. So we need to, as you can see in the picture, we need to apply a number of piles at different depths. So the first thing we do is we do the excavation. So it's telling us on the drawing here that some of the piles are at 600 mil deep and there are 450 mils. So we've got a number of piles which we need to put into the ground. We've got 3 kind of piles, and there's various different depths that they need to go into. So we've got a brace pile, we've got an ordinary pile, and we've got an anchor pile. So on the drawing here, it's indicated AOB. So A for anchor, B for brace, and O for ordinary. So we've got a few A's in here. We've got an A here and one A here. We've got a B here, and we've got a B here, and more B's at the front. So the majority of the piles are 600 mil deep. With the exception of the A anchor pile, which is 900 mil deep, and they're also asking for these front piles here to be 2 meters deep. So that's all of the ones at the front here. So all the O's and B's in this section are 600 mil deep, with the exception of the A's, and all the ones at the front here are 2 meters deep, including the A. So first we need to drill the holes. So what we do is we apply what we see here over to this spreadsheet. So we'll go with the bracing piles first, the ones that are 600 mil deep. So we've got an auger at 450 mil diameter for holes to take a 125 by 125 timber pile. So B's at 600 mil deep, so we apply the 600 mil, 0.6, and we know the diameter is 0.4, and according to the B for the 600 mil deep, there's only 2, so that'll be this one here. And also with the brace pile, we've got 2 meter ones. So these are these ones here, as you can see, all along the front. And we apply they're at 2 meters deep, and they're 0.4, and there's going to be 6 of them. So it's 1, 2, 3, 4, 5, 6. And we just follow that equation. So with the ordinary piles, these are at 600 mil deep. As you can see, they're along here. So there's 1, 2, 3, 4, 5, 6, 7. So we've got 0.6 deep at 0.4 diameter times 7. So with the anchor piles at 900 mil deep, we've got 1, 2, 3, 4, 5. So 0.9 times 0.45 times 5. And also with the anchor piles, we've got a 2 meter deep one, which we can see in this corner here. So this will be 2 meters times 0.45 times 1. So we allow wastage on this because when the earth's in the ground, it's compressed. When we dig it out, it expands a little, so you get more earth that's going to be carted away. So we allow for about 10% for that. And a total, we need 11.83 cubic meters to remove from site. So with the timber piles, we just need to know how many there are and what they are. But we also need to allow for the part that comes out of the ground as well. So that information hasn't actually been given to us for any drawing. So we're going to assume that these are going to be at 1 meter. So we're going to allow an extra 1 meter on top. So based on the pile length of 1 meter from ground level to finished floor level. And ground level will be from where the concrete ends up to the underside of the bearers. So we're supplying and fitting 125 mil by 125 mil H5 treated timber pile to augered holes with 100 mil encasement. So we need to base of the pile so that no water ingresses into the pile, and it just protects that. So what we do is we take the depth of the hole, and we also know we're going to add a meter onto it, so should be 1.6 meters, but we need to take off 100 mil for the encasement. So all we're doing is adding 900 mil to the 600 mil here, which will give us 1.5. And we know there's 2 of them, and we just times that by 1. And with the 2 meter one, we are adding 900 mil, and there's 6 of those, and there's just 1. And with the ordinary piles at 600 mil, again, we're just adding 900 mil, there's 7 of those, times 1. So with the anchor pile at 900 mil, we're adding an extra 900 mil, that gives you 1.8 meters, times 5 of them, times 1. And with the other anchor pile at 2 meters deep, we're just adding another 900 mil for that, so that gives you 2.9 meters, and there's 1 of those, and you finish off with a 1. And again, with the same with our wastage as well. So you get a total of 47.8 linear meters of H5 125 by 125 timber piles. So next we actually look at the concrete. So we've been asked to supply and pour 25 MPa concrete to the pile holes. So we just bring the same quantities down because it's the same piles at the same depths. We now need to make an equation so we can work out how much concrete's got to go into these holes minus the size of the pile. So over this side, this is where the equation is. So we need to measure the concrete. This gives us a total value of the concrete within the hole if there was no timber pile. So the way we come to this equation, we take the diameter, half it, and that gives us 0.225. And we times that by 0.225, and that gives us 0.051. And then we need to bring pi into the equation. So we take pi, that's 3.149, and we times it by the total of 0.5, which gives us a total of 0.0159. And that will be the same from all because they've all got the same radius. And then the next equation is we apply the depth. So we just bring these numbers that we've got in here. So we've got 600 mil, 2 meter, 600 mil, 900 mil, 2 meters. And then the final equation is we times 600 mil by the 0.159. And that gives us 0.096 for the 600 mil pile. So that's all the concrete within that pile hole. Now we need to work out how much cubic meterage would the timber piles take up in those holes. So these are square piles, so we don't need to include pi into this. So the piles are 0.125 by 0.125. So the length, we're not going to go the full 600 mil deep because we need to take out 100 mil for the encasement of the pile from the concrete. So we take 100 mil away from the length figure. So this is the 600 mil deep one. So we're going to make this one 500 mil. The next one's a 2 meter one. So we're going to make this a 1.9. And this one we're going to make a 0.5. This one we're going to make a 0.9. And this one's going to be a 1.9. So all we do is we times all of these. So we times the width by the depth by the length. And that gives us a 0.008 for the 600 mil deep one. And so on for all the rest. Now it's a simple equation to work out how much concrete is required once you take the pile out, is you take the total concrete figure and you take out the timber figure. And that gives you a 0.088. And then all we need to do is just transfer all those quantities over to here. And now it's just a simple equation to fill in the rest in, which will be the same as what we got here in Quants 2. But it's just the amount of piles. So we've got 2 of 0.6, 6 of 2 meter, 7 of 0.6, 5 of 0.9, and 1 of 2 meter. And we just apply 1 to finish off the equation. And that gives us the total amount that we need of concrete for each pile. Plus we add on 10%. And we get a grand total of 3.82 cubic meters of 25 MPa concrete required to fill all of these piles. So we have the bracings here. We've got a 2 meter one, so you can see the highlighted area here where it's got 2 meters. So those are those ones. And we've also got 2.29. So those go from here to here. And there's only 2 of those. But because they're at an angle, we need to add extra value on to accommodate that. Plus also we need to add extra to connect them to the piles, because at the moment that 2 meters and the 2.29 is just between the posts. So we've made an equation for this. So we take the length of the pile. So we've got a 2 meter, which refers to this one, and 2.29, which refers to this one. So what we're doing is we're adding on 1 thickness of the pile, because it's only going to go halfway across the pile. So we're going to add on a 0.125, and that gives a total of 2.125. So for the angle, it's not much of an angle, and there won't be overly too much to add on each one. We're just going to add 20% of that. And 20% of the 2.125 is 0.425. And that gives us a total of 2.550 for the 2 meter pile. And that gives a total of 2.89 for the 2.29 pile. So we just need to transfer these back over to the figures here. So we've got the figures that we've accumulated here. We know there is 3 of them. So we've got 1, 2, 3, which refers on here, it's 1, 2, 3. And for the other one here at the 2.9, there's 2. So it's this one here and this one here. And we add our 10% extra on, which gives us a total of 14.79 linear meters of 90 by 90 H 3.2 treated bracing. We also need to include the bolts. So this is just a simple equation. So we put our heading in, and we know there's 5 piles just through these 2 figures here. So we've applied it there, and we know there is a bolt and washer at each end. So we times that by 2 and just finish it off with a 1. And we finish the equation off here and put 10 in. No need to put an extra value into it because there's no wastage on bolts. So next we've got the bearers. So these are the ones that sit on top of the piles here. These are made up of 2 190 by 45 H 3.2s. This is indicated here. So for this one here, which is the one at the back, so there'll be 2 pieces of 190 by 45 H 3.2 sitting on there, and the same with the front as well. So they're B1, B1, they're identical, and B2 is also identical. So we just apply these to our spreadsheet. So we're supplying and fitting of 190 by 45 mm H 3.2 treated timber bearers to piles, including stainless steel 12 kilonewton and 6 kilonewton fixings per connection. So the 12 kilonewton fixing will be a stainless steel plate, and half of it will be fixed to the pile and the other half will be fixed to the bearer at each end. And there'll be a number of screws that are fixed into there. And the 6 kilonewton one comes in the form of skewed nails or wire dogs. So wire dogs are just a bent nail which one end goes into the pile and the other end goes into the bearer. So we've got down here B1, there's 2 of 190 by 45 H 3.2 bearers. And we know the length is 12.35, as we can see up here. And there's 2 of those. And we've also got 2 to do. So we've got a B1 here and a B1 there. So that's another 2. So it gives a total of 49.4 linear meters. And then B2 is the same size product, 2 at 190 by 45 H 3.2 bearers. Again, it's 12.35 and there's 2 of them, but there's only 1 required. So we're only going to go into the middle here. And that gives us a total of 24.7 linear meters. And we add on our wastage and we have a grand total of 81.51 linear meters of 190 by 45 H 3.2. Thank you for watching. If you've enjoyed this video, please like and leave comments below. Please stay tuned for future videos on quantity surveying elements.